Good afternoon. This is our hour where we solve problems. Um, and Daria, I know you like to record. Do you want to record? Are we recording?
I think it's recording.
Okay. Um, so this question is about aquifers, and let me give you some background on the two different types of aquifers that we have. And um, so we have one type of aquifers called um, open aquifers, unconfined. In those aquifers, when you have this is your um, ground level, you have a water table, and when you have a well, the flow creates a water table to be like this, bends the water table around the well when you extract water. And um, this movement is called gravity flow, and um, the water table is max. Like the water table depends on how much you're pulling water out, but the maximum water table, if you don't pull any water out, is at the water table level. Another type of aquifers that we have is called confined aquifers. Um, so in confined aquifers, you have a clay layer. Either it's all the way clay layer to the uh, ground level, either it's all the way clay to the ground, or you have a clay layer cap and then there is a pervious material on top. But anyhow, when you make a well, and imagine this is your um, groundwater. When you make a well inside this previous material, like this is sand here, it's possible that your water table is above. And that's because um, this clay layer is impervious and there's a possibility of having some water here, um, and then these are pushed down because of this cap. The water has no way to go. So when you put a well inside, that pore pressure comes out. So um, to see if we have confined versus unconfined aquifers, you need to look at for this clay layer, and also whether the water table is above the groundwater table. When you put a well, whether the groundwater table is the same as where you get this piezometric pressure. A site investigation for a proposed industrial supply well in Atlantic coastal plain returns the boring log shown in the figure. Two piezometers are installed and allowed to equilibrate. PZ1, this one, screened in the upper silty sand from 6 to 7.5 meter below ground surface, stabilizes with water at 5 meter. Screened in the lower coarse sand on PZ2 screen. Okay, so let's look at PZ1 first. You have a sand layer here, and then when you put the well, the water table stabilizes here. And that suggests this is the water table in the soil. But when we put PZ2 screen in the lower coarse sand and gravel from 14 to 18 below ground surface, stabilizes with water at 2 meter below ground surface. The intervening clay layer extends from 8 to 12 meter below ground surface. Which of the following best describes the lower coarse sand and gravel and the appropriate steady state flow equation to use for a fully penetrating well screen in it. So this layer has both characteristics that we talked about for being confined aquifer. We have a clay layer here, and also when we put a well, the piezometer pressure shows a pressure above this layer, and that tells us this is confined. So just by knowing this is confined, we can remove option A. Um, Option B says it's patched aquifer. The clay supports a localized water table above the regional groundwater, so neither Dupuit or Thiem applies. So if you go to your manual, you have Dupuit's, Dupuit's equation for unconfined, and when you come down, you have a Thiem equation for confined aquifers. So for the problem that we have right now, the Thiem equation applies. Because the Thiem equation applies, this option is wrong. And option D says, because PZ2 reads 3 meters higher than PZ1, the lower aquifer is Artesian, and any pumping immediately dewaters it. So Dupuit gravity flow governs. Here, it has some words that's right, so it may confuse you. Artesian flow is the type of flow that happens in confined aquifers. So this flow, the flow that we see in PZ2 is um, um, Artesian. That's correct. But then it talks about pumping immediately dewaters it. That's not correct. You can have a confined aquifer and pump it for a long time. So this part is wrong, and this does it's not gravity flow. We just said it's Artesian, it's not gravity. So the correct option is option C. It reads confined. The clay acts as an aquitard. That's correct. And the piezometric surface in the PZ2 lies above the top of the lower sand. That's correct. So apply the Thiem equation. Yes, that's exactly right. This is the equation that we should use from the reference manual if we had a numerical problem. So is there any question on confined and unconfined aquifers? Part of this is in your geotechnical section of reference manual. Part of this is in your water resources section of reference manual. But during the exam, because your syllabus has groundwater in it, your question can come from either. So it's important to be familiar with both parts when you read the reference manual for your exam. Okay. Let me pause for a couple of seconds to see if you have any questions. Thank you, and I wish you best luck for studying for PE. And if you have any question, or if you are interested in certain type of problems, like I'm interested in looking at a seepage problem or something, let us know. We can do that next week. Have a good week.